Hello, let's try to understand continuity of a function in terms of limits. Okay, now to explain you, let me just make a sketch and show you one function, right? And then from there we'll discuss. Let's say we have a function and let's say this is my point A and this is my function. Let me draw the function in different color. So it starts from here, let's say, and goes like this. Let's say we have a hole here, right? And then it goes like this. And on this side, let's say starts from here and then goes like this. Clearly, this function is discontinuous at point A, right? And also at point B, right? This point B also, it is discontinuous. Let's say this is my x-axis and this is my function f of x, the y value, right? And here we have 0, right? So here what we see is that as we go from minus infinity towards plus infinity, we find at point A, it could be 1, 2, 3, 4, any particular value. But in general, at point A, it stops here and there is a hole, so that means it is discontinuous here and it is not defined at point A. So it looks like it's line y equals to x, and but the domain of this line is defined from minus infinity to A, not including A. Now after A, the function takes a different turn and it starts from some other value. Let's say this value here and this value here. So which value is f of A? So at A, the value of the function is not this. See, this is the whole, right? So at A, the value of the function is this, and we call this as f of A, right? That's the value function at A, correct? Since it is, if you see there's a hole, right? So we have to see what value, well, it takes, this is a filled in thing, right? So this is from where it starts. And it seems it is like a part of a polynomial going down, and at B again there is a hole. Now what is the value here? So this value is, the coordinate of this point will be B for the x value and f of B. I'm purposely using different formats so that, while explaining you this simple concept of continuity, I can also explain you many other things, right? These are the different ways of writing a function and in using function notation, coordinates and things like that, right? So at A, the value of the function is f of A. At B, what happens? At B, there is a discontinuity and then we have another piece attached to it. It looks like another polynomial, right? We're not very sure, could be a parabola kind of part of, right? Who knows? Now let's say it doesn't really matter, but it's definitely a function which is continuous thereafter, but the two are joined together with a hole in between at B. So there is a discontinuity here also, right? So we definitely see that the function is not continuous at all. But this will help us to understand what is limit and how does it help us to find whether the function is continuous or not. Well, now let's see from the limit point of view. So let's say, now what is the limit of the function f of x? Try to answer this function. Limit, L should be small actually, of the function as x approaches A of function f of x, right? Let's say from minus side. From minus side, right? For simplicity, I would like to give some values here so that, we have some y values and we can talk about them. Let's say this value is 2, right? And let's say this value is 4. Let us say, right, fa equals to 4, and at this point we have a number 2 here, and let's say this point is 2 and this point is plus 3, correct? Let's say these are my points here, and let us say this point is also 2, okay? Well, so yeah, your concepts have to be very clear to understand when I say 2, then what I mean and which point am I talking about, okay? That's fine. So as you approach A from negative side means this side, right? Where do you approach and what is the value? So limit of the function as we approach a from the negative side of this function is actually 2, right? Limit is actually what? Limit is not the value at that point. Limit is the value which you approach to, right? So as you come closer and closer to a from left hand side, this minus c is from left hand side, you actually approach f of x as 2. So that is the value, right? How about limit of this function as we approach a from the positive side? From the positive side, if you see coming from here, right, then you are approaching a value f of a, which is 4, right? So we say from the graph, it is equals to 4, correct? Now, since these two limits are not same, that means the function is discontinuous, one thing, right? More than that. Now, if I ask you what is the limit of the function as x approaches a, now let's say if that is my question, what is the limit of this function as x approaches a? So what will you do? You will check the limit from both sides, left side and right side. If they are equal, then the limit exists. Now here we notice that left side limit is 2 and the right side limit is 4. Oh my god, so they are not same. So we say it does not exist. So in the short form I am saying D and E does not exist. And the reason why it does not exist is because we can write like this for because, right? If you write opposite type, like therefore, this is simple for because. Because limit of x as it approaches from minus side of f of x is not equal to limit of x as it approaches a from positive side, right? That's the reason why the limit does not exist at the point A, okay? So limit does not exist at point A. Now let's try to analyze point B now. Now point B, if you look at, so what is the limit of the function as it approaches from B? So we'll write here, let me just write here, you see limit as x approaches B, and let's say from negative side. If I say from negative side of f of x, can you tell me what's the answer? Well, the answer is f of b, which I'm just extending this to point 2, right? 2. How about the limit of this function as we approach b from the right side? If you approach from the right side, you also approach the same value. So we get limit of x as approaches b from positive side of f of x is also 2, right? So the limit exists here because from both the sides we get the same value and the value is 2 for us. Now the question is, if I say what is the limit of function f of x as x approaches b, you say, well, which is 3 in this case, right? I'm not writing 3, but I'm using b. I could have written 3 also. You say it is 2. Why is it 2? It is 2 because when you approach b from left side or from the right side, you get the same value, which is 2. Therefore, the limit exists, and the limit is 2. Right? But still, you see that the function is discontinuous. Why the function is discontinuous? Limit exists, but the function is still discontinuous. There is a hole there, so the function is not continuous there at all. So the function is discontinuous because what is the value of function at b? The value of function at b is not defined. That is why it is discontinuous, correct? Now, if I add something here and I say, well, let me define our function at 3 also, right? Or at b, right? So if I say, how can I make this function continuous? Then the question is, how can you make f of x continuous? That is the question, right? The only way you could make it continuous is to define another function so that it has a value at b and which matches with this value. That is a limit. Only then it could be defined, right? So the answer to this is only if I define another function g of x, which is equal to, in this case, 2. G of x, which is equals to 2 if x is equals to, let me say b, which is 3 in this case. So if I define g of x equals to 2, then what really happens is, then we really fill this up, right? So what we do is, we fill this up. That g of x is filling the hole here. Do you see that hole filled up now? So now, if I fill this up, then it becomes continuous. Do you see that? So, the function becomes continuous if, 1, the limit exists, second, the function is defined at that value. Earlier it was not defined there either, right? So three things which we have, which now we conclude are like this. First value is that function, let me say f of x is defined, right, at that point. Is it okay? Or then it is continuous at that point. This is the first condition. And second condition is that limit should exist. At that point, correct? And third is that limit should be equal to the value of function, right? Limit at f of x at that point. Does it make sense? So three things are very important for continuity in terms of limit for a function, and that is very good application of limits. We use limits to find whether a function is continuous at a point or not. So the condition is that point should be in the domain of the function, right? Earlier, before we introduced g of x, that point b was not in the domain of the function f of x, right? So it was discontinuous at that point, right? F of b didn't exist. So I have written b f of b, but it didn't exist, right? This does not exist, right, earlier. Now, and therefore it was discontinuous. We found that the limit at this point existed, and it was 2. Still, the function saying that limit exists and it has a value does not necessarily mean that the function is continuous at that point, because limit is approaching that point, not at that point. You're just trying to approach. You're very, very close to it. Well, but if the limit of the function is same as the value of function, only then we can conclude that the function is continuous at that point, right? Still, you can see this function remains discontinuous at a, that is at 2, correct? And this kind of discontinuity is called a jump discontinuity. We'll talk about 3 different types of discontinuities. One is a jump, second is the hole, and the third one is infinite, which you see in reciprocal function, a vertical asymptote kind of, okay? We'll discuss those in different videos, right? But here my emphasis is more on the continuity in terms of limits. I hope you appreciate and understand it. If you have any questions, do put in the comments, right? And then we can sort them out. Have a good look at this, okay? Thank you.